Let's talk a little bit more about the NAT Traversal problem. So this is a problem that occurs when the client outside of the NAT box tries to reach a server behind the NAT box. You see, in such a case, clients will be sending messages, and in these messages, you see that the destination will be what? The IP address of the server. So 10.0.0.1 will be here. And this message will be sent out of the client, and hopefully it will traverse the internet, reach the NAT box, and then down here inside the local network. But some of you might be sensitive enough to see, hey, all these machines are behind the NAT box, and these machines behind NAT box are operating on fake IP addresses, meaning these machines, none of them are addressable from a machine outside. That is also saying that that message with 10.0.0.1 being the destination won't be able to reach the NAT box, and of course won't be able to reach the server. So that is our NAT traversal problem. And the solution is exactly this. Tries to make sure that the client is aware. Therefore, the destination in the message is going to the server will be assigned to this IP address, the global IP address that is allocated by the ISP to the home network. So there are generally 3 solutions, so we'll talk about each of those. The first solution is very straightforward. It's called the manual configuration solution. Let's assume that the server process is running on this machine, IP address 10.0.0.1 at port number 25,000. So all the solution is doing is just to insert an entry manually to NAT's translation table such that for all messages coming with this as the destination address, this is the destination port number, they'll be translated to the local IP address and the local port number correspondingly. As a result, the messages will be able to travel through the internet and reach the NAT box with this global IP address. And the NAT box will translate according to the entry here and forward the message further on and eventually reaching the server process. Solution 2 is the exact opposite of solution 1. Instead of doing things manually, we now do things automatically. And the thing we're hoping to do is to set up the global to local IP address port number mapping in the NAT box. And the server needs to know the global IP address and the global port number so that it can inform all the clients outside trying to reach it. Okay. Now, from the server's point of view, the IP address, local IP address, and the port number the server process is running, these are conveniently available. What are a little bit far-fetched are the global IP address and a free port number at the NAT box that can be used to do the mapping. So how do we do that? Yeah, guys, it's done by this protocol, Internet Gateway Device Protocol. So by Internet Gateway Device, they actually meant the NAT box. So both the NAT box and the server box, to support IGD, there needs to be additional software being implemented. Okay. So between this software at the server box and this software at the NAT box, messages are exchanged. Okay. Through the exchange, simply, server side sends a message to discover the NAT box. NAT box, after being discovered, send back the global IP address configured to the NAT box. And the NAT box will enumerate the port numbers that have been already assigned and find out what is the next free port number. Okay, so enumerate through existing port number to find one free port number. So such global IP address and a free port number will be sent back to the server box. In the meantime, a global local. IP address port number pair entry will be set up in the NAT translation table. Okay. So all the clients knowing the global IP address and port numbers can now then send messages and reaching the NAT box. NAT box translate to the local IP address and port number, eventually reaching the server process. What's even nicer is this. When we configure a home network behind NAT like this, we set up also DHCP so that we could automatically configure these local machines' IP addresses. That is also saying the NAT box here knows when you're using the IP addresses and when you no longer need IP addresses. When the lease time expires, the NAT box can automatically reclaim the port numbers so that they can be reused in the future. Nice. Solution 3 might be familiar. We've introduced the mechanism when we talk about Skype in chapter 2, the P2P applications. And the problem is the Skype client nowadays, like you and me, are often behind NAT routers. So this guy here also behind NAT router. So they won't be able to call each other directly. Nope. Instead, in Skype, what we do is to find supernodes, such as this guy in the middle. A supernode actually operates using global IP address, meaning they are not behind NATs. So this guy here can establish a connection to such a supernode, no problem. Similarly, for the other guy here, a connection can be established. The supernode here then will work like a relay and bridge the packets going from one way to another and vice versa. And this is how a client here and a client there can try to establish voice communication. But this is, however, is not the only way that Skype get around the NAT traversal problem. Skype implements also this IGD, which is the solution to we just talked about. So in Skype client, there's this software part of IGD that used to run on the server box in solution 2 scenario. And there's a software that runs on the NAT box. So message can be exchanged to discover the physical IP address, the global IP address, and discover also a fresh port number. So with the pair of global IP address and fresh port number and the mapping established here, that information can be sent to this client's friends. And therefore the client can use the global IP address and port number and call directly to the NAT box, and NAT box will translate it so that the call will reach directly to where the Skype client is. Okay. So that's a direct call without the need of having a relay node.